Hello, can you hear me?
All right.
I just want to make sure you can hear me in case I have a question.
So I was telling a few people at the beginning, sorry about Monday or Tuesday. The school literally changed their mind Tuesday morning, and the dean sent out an email, and the department chair sent out an email specifically saying we can't have online classes. So it's like, okay, I think some people complained that they couldn't do it. I don't understand why. We've had 2 years of doing this. We should be able to have online classes now, but it is what it is. So what we're going to do is, because I still want to have the test next Thursday. So I eliminated section 8.3. So we're just going to do section 9.3 today, the differentiation part, the separable equations. We'll still do the review next week. The review test is already up online. It's on the post for today, and I'll have the video posted because I realized I didn't post the last video until this morning. The video today will be posted when I get home. So
no 8.3 on the test, and we're doing 9.3 today.
Yes. Yeah. So it'll be 8.1, 8.2, and 9.3 on the test. So it's still 10 questions. It's 3 from 8.1, 4 from 8.2, and 3 from 9.3. So I don't think it's compared to the last, like I said, the chapter 7 test is typically the hardest test. This test is not too bad. It's a couple equations. As long as you remember how to do the integrations, you'll be fine. So, and I made the review test and the test at the exact same time. So the questions are very similar, just changed a couple numbers here and there. So, all right. So separable equations. So one of the two options that you have when you leave Calculus 2, you can go to differential equations, or you can go to Calc 3. Depending on what you're going, most places you're going to need them both anyway, depending on what your major is going to be in. So it's one half dozen or another. I typically would say go Calc 3 and then do differential equations, but they're basically equal classes at that point. This is the beginning or the introduction to what differential equations are. There's a lot more to it than what I'm going to show you here, but it's the first thing we're going to look at. What we're going to look at here is what's known as separable equations. So we've looked at dy, dx. We've had the dx's and dy's and stuff at the end. We've had the integral symbol, but we really haven't used them. They've more been just there because it's part of the format to keep them there. Those actually have meaning. So we have dy dx equals dx f of y. So it's like that's the derivative of that. And we can actually, and it doesn't matter if it's multiplication or division. We're going to do the division one because it's easier to see. You can actually split those up. So like we can have h of y times dy. We just did cross multiplication. Okay? So you could treat it like a fraction. Well, now if I take the derivative of both sides, the derivative and the dy will cancel each other out. And what's left is the function, the original function of what I would have. So we're saying the derivative is this with the multiple variables. What's the actual original function that I'm going to have? What is the f of x? What is the f of y or the gy? As crazy as it sounds, it's not as complicated as it sounds. All right, let's take one. So we have maybe. Because my thing is totally glitching now. Hold on. Apparently I clicked way too many things at once. Okay. Hold on a second. I don't know what's going on with my computer at the moment. But I'm going to close down some other stuff that might be causing problems. Okay, hold on. Really? Okay. Apparently, Grammarly is taking up all my power on my computer. Sorry. Now it works. All right, so dy dx is x squared over y squared. The goal is to, as best as you can, split this up so that the y's are on one side and the x's are on the other side. That is not always going to work. That is not always going to be the case. But that is our goal. So in this case, we will cross multiply. So I have, so this goes to y squared dy equals x squared dx. Okay, so we basically just cross multiply. I want to now get rid of my dy and my dx. To do that, I take the integral of both sides. So we're going to take the integral of both sides. So it's the integral. So as long as this and this match, we do the integral as normal. If not, we basically end up having to do the chain rule, which I'm going to show you in a little bit. So we're going to be able to just do the integral as the integral in this case. What's the integral of y squared? Y to the third over 3 plus c. Now what's this side? It's third over to the third, x to the third over 3 plus c. Now, you do not need to have plus c on both sides. We just have to have one of them. So typically, you keep it with the x. It doesn't make a difference as long as you have one of them. What you don't want to see is, I have c on both sides. I can cancel them out. No. So the plus c on this side is really c1. That's really c2. And when I move them together, it's still going to basically be a constant. Okay, so it's not like they would cancel each other out. So as long as I have a constant in the problem, we're good. All right, so are we good to that point? Yes? All right. Now, what we want to try to do, if you can, is to solve this problem for y. You want to get the y by itself. So I have y to the third over 3 equals x to the third over 3 plus c. So what's the first thing you're going to do if I want to get the y by itself? Multiply everything by 3. So I get y to the third equals x to the third plus 3c. Right? Okay. Now what's the next thing I'm going to do? Yep, take the cubed root. So y equals the cubed root of x to the third plus 3c. You can now make this 3c anything you want. It doesn't matter. Remember, it's a constant. I don't know what it was to begin with. So you can actually just make this any letter you want. They use K, you can use M, whatever you want. Doesn't make a difference. It's still a constant. Okay. Are we good to that point? Okay. So they gave us one other piece of information. They said, find the solution to this equation that satisfied the initial condition of y0 or y of 0 equals 2. So what that means right there is that x is 0 and y is 2. Okay? So we're looking for the value that will give me that to be true. Think about, remember, f of x is just y, right? So y of 0 doesn't mean that y is 0, it's y of 0. It's y of that function. It's y of x. And y of x is 2. So that y value would be 2 in that situation. And then the value inside the parentheses would be my x.
Same as like f of x.
Yeah, it's the exact same thing as f of x. They just use the y to confuse you. All right, so we've got that information. So we're going to plug that in and solve for k. So y is 2, the cubed root of 0 to the third plus k. So 2 equals the third root of k. What do I have to do to get rid of the third root? Cube root both sides. So the cube of 2 is 8. So k equals 8. So my original equation for this problem is x to the third plus 8. And the derivative, the dy dx of that, is y squared over x squared over y squared. So this was my derivative, and that's my original equation. Okay. The difference is, so like if I told you to take the derivative of this or the integral of this, okay, the way this is set up right now, can you take the integral? Huh?
No.
Please.
I need some stuff.
Oh, actually, you're not doing it. You're doing derivative. So, but yeah, like the way that it's set up, you couldn't really do that. But if I got rid of the third and moved it over, I might have some options there. Could you do the derivative of that? Let's try. We'd have to use we'd have to use the chain rule for this one. So let's try the derivative of it. So I have y equals the cubed root of x to the third plus 8. So that's the same thing as saying x to the third plus 8 to the 1/3 power, right? Yes? Okay. So if I would take the derivative of the inside, which is 3x squared. And then I'd multiply that by, I'd bring down the 1/3. And then it's going to be the x to the third plus 8 to the negative 2/3 power. Right? So chain rule. So we did the derivative of the inside. is a 3x squared. And then I do the derivative of this as if it was u or whatever else. So u to the 1/3 is 1/3. You bring the 1/3 down and you subtract 1. And that's where the negative 2/3 comes from. Okay? So if I cleaned all this up, I would get x squared over the cubed root of x to the 3rd plus 8 squared. Now, if I had taken this and got rid of the cubed root, if I made that y to the 3rd equals x to the 3rd plus 8, and I did the derivative of both sides, that's y squared dy equals 3x squared dx, which brings me back to, if I get the dy over dx on this side, equals x squared over y squared. So it gives me, if you plug numbers into this, you'd get the exact same thing. Okay? Just sometimes using the separable equations makes our lives easier. The confusion part is you're taking the derivative of two different variables at the same time. Okay? So the nice thing is, though, that this doesn't necessarily have to be a function for me to take the derivatives of it. Pretty much everything up to this point had to be a function. All right? Had to be f of x or y or g of x, or it had to be in terms of something that was a function. This allows me to move past that function concept. Okay? Which, when we go into chapter 10, which we're going to do at the end of the semester, when we're looking at polar equations and parametric equations, again, it's looking at things that are non-functions and how I can do calculus with those. Okay? All right, so let's look at this one. So I've got dy dx, 6x squared over 2y plus cosine y. Nice thing is the way it's set up, we can easily split this up. So I have 2y plus cosine y dy equals 6x squared dx. So take the integral of both sides. The integral, yes. Because the goal right now is to get rid of that. And to get rid of the derivative, I have to take the integral, because those will cancel each other out. Which one? Negative y? What's the derivative of 2y? Y squared. You're going to the derivative side. Easy mistake to make. And the nice thing is the 2 cancels out, so I don't have to worry about the 2 in front of it. So that's just y squared. What's the integral of cosine y? Again, you did the derivative. It's sine y. What's the derivative of 6x squared? Or the integral of 6x squared, sorry. I got, 2x cubed. Now you've got me doing it. Plus c.
Does it matter where you have to put the constant?
No, it doesn't. Now, this one. Yes,
So we take the derivative of the left side and the integral of the right.
they're doing the integral of both sides. Because the goal is to get rid of the dy and the dx. To do that, we've got to do the integral. Because the integral and the dy cancels out, the integral and the dx cancels out. So now, can I solve this for y? Can you get y by itself in this problem? Yeah, you're not going to be able to get y by itself in this problem. So a lot of times when you have multiple ones, it's going to be very difficult to get y by itself. Unless you can kind of get the stuff together and factor it out, which can happen sometimes. But there's no way to get the y out of sign without doing the arc sign. And then I have the y squared there, which is going to be a mess. So there's just no way to get the y by itself in this case. So in this one, it's done. There's nothing I can do. And they didn't give me a point to find C. So we would leave it just like this. Okay. If they gave me a point to find C, I'd plug that point in and be able to find C from that case. All right. What's y prime mean? Yeah. Y prime is the exact same thing as dy dx. Okay. They mean the exact same thing. One's Newton, one's Leibniz. All right. So change that and solve this problem. And this one you should be able to solve for y. So you want to solve this one for y. Sorry, I'm just looking for a problem because I want to do a different problem that I have. All right. So what do we got? So how do we set this one up? Yep. Got that? What's next? Okay. So this becomes dy equals x squared y dx. Divide by y. So I have 1 over y dy equals x squared dx. Yep. So this side, what's the 1 over y become? Yep. ln of y equals, yeah, I typically put the c on the x side, but like I said, it doesn't really matter. X to the third over 3 plus c. Okay. How do you solve this for y?
Y is equal to e to the power x cubed over 3 plus c.
Y is equal to what?
E to the power x cubed over 3 plus c.
Okay. So to get rid of ln, we have to raise everything to the e, right? Or e raised to everything. So this becomes, if I put e underneath everything, basically, those cancel out. So I have y, and then I have e to the x to the third over 3. Now, plus c. Is there a way to split that up so I can get my constant by itself? Yeah, remember addition for exponents, when we're multiplying the like bases, the exponents get added. So this right there is the same thing as saying e to the x to the third over 3, and then e to the c. So that right there, that's my constant. So I can literally just call that a, x, y, whatever. Not x or y, but any other capital letter you want. So the final answer for this one is a, e to the x to the third over 3. Because remember, you kind of want your constant as a constant. You don't want it as part of your problem. All right, let's try. All right, let's look at this one. All right, so what do we got to do first for this one? Yeah, we're going to change this right here to dy dx. And then I can move the dx over, right? So I have x ln of x dx equals y 1 plus 3 plus y squared dy. All right. So let's work on this side first. So I have x ln of x dx. Let's find the integral of that. How do I do the integral of that? Huh? Yeah, we got to do integration by parts. So we're going to have to do that. So u to u, v dv. Which one am I going to make u? X. And then du becomes just dx, right? And then the derivative or the integral of ln of x is 1 over x. So let's see if this helps me or not.
Isn't the derivative of natural log of x equals 1 over x?
Oh, you're right.
I think u should be ln of x.
Yeah. You're right. I did the derivative again. Because how easy that is to mess up. All right, so let's switch it. Let's do this. Let's make that ln of x, which makes that 1 over x. And then we'll make this x. So the derivative or the integral of x is x squared over 2. All right. That's right, because lattice, the L is logs. That's always first. All right. Those wonderful acronyms. So what do we got? So what was the integration by parts? UV. So U is ln of x. V is x squared over 2. The integral of v, x squared over 2, du, 1 over x. So this side is x squared over 2 ln of x. That's pretty simple. This part in here cleans up to be just x over 2. Because the x's cancel out. Okay. So that becomes what? What's the integral of x over 2? X squared over 4 plus c. All right. So we've got that side done. Now let's look at the other side. So we've got all right. So what's the first thing we want to try in this one? What do you mean?
Like multiply y on both sides.
Yeah, let's distribute the y. So I got y plus y squared of 3 plus y squared dy. So now I could actually do the integral of both pieces, so I don't have to do that. So what's the integral of y? So that's just y squared over 2. Okay. And now we gotta do the integral of this. How do I do the integral of that? Okay, so what am I using to substitute?
P plus y squared.
Okay, so then du is
Y.
2y dy. I have a y, so I got to move over the 1/2. So the reason this works is because of that y. Okay. So the integral of the square root of u, 1/2. Okay, so what happens? This becomes what? You did the derivative. You're adding one. So it's u to the what? You're adding one. You're subtracting one. You need to add one.
Oh, yeah.
3/2. Times 3/2, or 2/3, because you just flip it over. So this equals 1/3 the square root of 3 plus y squared to the third power. All right, we're not done. We've done the integral of both sides, but now I got to put it all back together. So we had, what was it?
Squared.
No, it was a square root cubed.
But you were the other.
Right. So this is the same thing as that.
But we had a square root of.
We had the square root of it. Okay, I'm lost. What are we talking about? I'm missing something of what you're saying. So I took the u. So this is correct, right?
Oh, I see. You're right.
I plugged back in the u. I know. I think the book left it as derivative.
I read that.
No, that's backwards.
That's backwards.
Yeah, the denominator is your root. The exponent is your numerator. So it's the square root. That's what that says. That root.
If you have that.
Yes. That's that. Because that's a 2 and that's a 2. So 2 divided by 2 is 1. But the 3 is inside, the 2 is out here.
Oh, okay.
So. Okay. All right. Can I write the first part? I did that. X squared 2 over ln of x. Plus x squared over 4, if I remember right. Yep. Equals y squared over 2 plus 1/3 cubed root of 3 plus y squared cubed. And the original point that I was plugging in was y of 1 equals 1. So x is 1 and y is 1. That makes my life a little easier. All right, so first thing, Can I solve this for y? No. So we're going to leave it. We do want to find out what c is, though. So I got to plug the numbers in and find out what c is. So I've got, what's ln of 1? 0. So I don't even have to worry about that part there. So I got 1/4 plus c equals 1/2 plus 1/3 the square root of 4 to the third power. So 4 to the third power is 64. The square root of 64 is 8. So, and if I bring over the 1/4, I have 1/2 minus 1/4 plus 8/3. So common denominator is 12. So I have 6. Where? That one?
Natural log of x minus x squared over 4.
Was it minus or plus? Oh, it was minus. So what happens when I switch screens? Okay. And then 8 would be 24? Yeah, 32.
Yeah.
Multiplying it by 4. So 32 plus 9 is 41. So C is 41 over 12. So I can just replace that C with 41 over 12. And that's my final answer.
When you see that, do you want us to circle like finding C or finding like the whole?
Your equation would be your answer. So that top line would actually be your answer to the problem. And look, I think, hold on. Let me just look at the test real quick. Or that practice test. I think I have one of each, if I remember right. Yeah, I have one you have to solve and one you don't. All right. How good are you with these? Not too difficult. The hardest part is remembering which direction you're going. Remembering if you're doing integration or derivatives. That's the mistakes that most of us are making, including myself. I'll add myself into that situation. All right. Let's do the fun problem then. All right. So we have a tank containing 20 kilograms of salt dissolved in 5,000 liters of water. The saltwater pool. So the brine that contains 0.03 kilograms of salt per liter of water enters the tank at a rate of 25 liters per minute. The solution is mixed and drains from the tank at the same rate. So as 25 liters per minute are going in, 25 liters per minute are going out. Okay? The 25 liters per minute going out is the same as the mixture of the tank. It's not exactly what's coming in. Does that make sense? Okay. So think about it this way. We have a pool. Draw. We have a pool. This is my in. and it's 0.03 kilograms at 25 liters per minute. Okay. It's being mixed in here. And then my out is also 25 liters per minute, but it's whatever's in the tank. Okay, because that water is coming in, being mixed around, and then there's water coming out. So the coming out is not 0.03 kilograms. I don't know what that is. That's whatever the mixture of the tank is at the time. Okay? Does that make sense? Okay. So we want to figure out how much salt's in the tank after an hour. So we're putting, in essence, 0.03 kilograms of salt per liter. We're putting in less salt coming into the tank than is already in the tank. So would you expect your tank to have more salt at the end of a half hour or less salt? Less salt. Okay. And actually, if you want to do a quick little thing, if we did 0.03 times 5,000, oh, actually, never mind. That doesn't work that way. Actually, yeah, well. So we have 0.03 times 5,000 is 150 kilograms per salt per 5,000. So actually, there's more salt going in than is already in there. It's 20. There's 150 kilograms of salt per 5,000 coming in. So we're going to expect the tank to get more salt, not less salt. Okay? Yes? That's important. Out of the whole concept, that's important. Because when you do your final calculation, the answer has to make sense. So if you get something that doesn't make sense, you have to understand why it doesn't make sense. So do you understand where I got the 150 from? So if we want to compare what's in the tank to what's not in, what's coming in, we have to get them the exact same. So you can do this one of two ways. We can either take this and make it 5,000, which is what I did by multiplying by 5,000, or you can take that and divide it by 5,000. So you can figure out how much salt per liter we have in the actual tank already. Okay? Either way, you got to get the units to be equal. All right? So if you took the 20 and divided it by 5,000, you have 0.004 in the tank. So in here is 0.004 kilograms per liter of salt. And we're putting in 0.03 kilograms per liter of salt. So the salt content's going up.
The one versus there's 20 kilograms of salt in the 5,000. Let me add that.
No, that's what I just did here.
Okay.
So in this salt water right here, so this water right here is 0.004 kilograms per liter of salt.
Oh, I see. Okay.
Because I divided.
Yeah.
I'm putting in 0.03. So my salt content's going up. So we're going to expect when I get my answer after a half hour that the salt content is going to be higher than I had to start. It's going to be higher than the 20 kilograms of salt in the tank. That makes sense? Okay, so when we do our calculations, that we should have a general idea of where we're going, especially whenever we're doing word problems. All right, so now we have to come up with our equations. Why is this a differentiable equation? What does differentiation give us typically? When we're taking the derivative of something, we're defining change over time, right? We're finding slope. I'm giving you what the change is. Okay? It's the 0.03 kilograms per salt coming in. That's the change. And the rate is 25 liters per minute. So those are both derivatives. Okay, those are both in terms of change. So if I want to find the thing that I have to start with, I need to do a differential equation. Are there other ways to do it? Yes. This just happens to be the way we're going to show you. All right, so we have our dy dt, so our change over time, is my rate in minus my rate out. So that's going to tell me how much more salt's in the tank. So how much salt's coming in versus how much salt's coming out. So my rate in is 0.05 kilograms per liter. Right? Oh, 0.3. You're right. It was 0.3. I really got to stop switching screens. All right, so that's coming in. And it's 25 liters per minute. So I have 0.75 kilograms of salt coming in per minute. So that step makes sense. Okay. Now our rate out. Do I know how much salt's in the tank? I know it at the start, but I don't know it once we start, right? That's my equation. Okay. That's the function. So I have y of t kilograms over liter. Again, times the 25 liters over minute. Oh, sorry, over 5,000 liters. Because I know how much water is in the tank. So this ends up being y of t kilograms over 200 minutes. All right, so do you understand why my derivative is the rate in minus the rate out? Okay. What's the question asking me?
How much salt is it in that?
Right. We want to know how much salt's in it. So the function that I'm getting, the y of t, is how much salt is in the tank. Okay. So we know when we started, we had 20 kilograms of salt in the tank. So, but as that goes on, that changes. That's why it's a function. So that y of t is how much salt's in the tank. Okay. So, and then it's coming in, the rate is 25 liters per minute. That's how much it's changing. Okay. So we good to that point? All right. So now we can come up with our, that is going to be my dt over dy. Yeah. Or dy over dt. So it's 0.75, right? Yep. Minus y of t over 200. All right, so let's clean this up a little bit. let's make this one thing so I can easily do the multiplication on both sides. So if I get a common denominator, I get 150 minus yt over 200. Now I want my y's on the side of the y. I want my dy over on, so basically I want my dy on the right side and my dt on the left side. So if I cross multiply, they're going to be on opposite sides, which is fine. We can do that first. And then I just divide both sides. So I get 200 or dt over 200 equals dy over 100 minus y. T. All right. So up to there, how are we? Are we good to there? Okay. So that's my equation. Now I got to do my integral with it. So what's the integral of 1 over 200? Yeah, it's just t, right? It's just t over 200. And you can ignore the t, and you can literally just look at it as y. You don't have to necessarily have the t there. So what's this side going to be? Almost. It's minus ln. Because if you do, you have to make, in essence, you're making u substitution. So if you make u the 150 minus y, du is negative y. Or negative u. So that's where the negative sign comes out. All right. So we've got this equation right now. Do we have a point to find C? Because to find 30 minutes, I'm going to have to find what C is. What information did they give me at the beginning to know? Nope. That's the question. Nope. That's the question. Would they give me at the beginning? At time of 0, how much salt's in the tank? 20. The tank contains 20 kilograms of salt to start. Okay. That's the first point. So I have a point. At 0 time, I have 20 kilograms of salt. So when time is 0, y is 20. I can now use that to find C. Common denominator. I just multiplied that by 200. So C equals negative the ln of 130. All right, so my equation that I have now is T over 200 minus ln of 130 equals negative ln of 150 minus y. So the question asks how much salt's in the tank when the time is 30 minutes, right? So I need to solve this for y. Yes. So there's a couple different ways we can do this. We can take this right now as it is. And since the question only asks you, well, there's only one y in this problem. So I can get the y by itself. Okay. And this is really one of those questions where it comes down to what did the question ask you? The question just asked you how much salt there will be in the tank after half hour. So I can just plug in 30 to T and solve for y now that way. Or I can solve for y and then plug the 30 in. Believe it or not, it doesn't make much difference. It's not going to save me time either way. I still have to do all the processes out. If you are going to be doing multiple ones, you would want to solve for y ahead of time and then do it. Okay? For this situation, I'm going to solve for y first, and then we'll plug in the 30 because I want us to see something after this point. I'm going to ask another question. So let's solve this for y. First thing we have to do is whenever you have multiple ln's, get them all on the same side and put them together. So I have T over 200 equals ln of 130 minus ln of 150 minus y. So I have subtraction gives me what? Division. So I have ln of 130 divided by 150 minus y. And this is so not going to help get my y by myself. All right, let's try a different way. That would work, but it's just not going to get y by itself. All right, if we take e to the both sides, I have e to the t over 200 minus ln of 130 equals, and the negative sign, let's move this up top here. So I've got 150 minus y to the negative first power.
Negative side and the other side.
Yeah, let's do that. We can do that. Let's get rid of the negative sign over here so I don't have to deal with that part. Good call. So minus, plus, plus. Okay. So I have e to the ln of 130 minus t over 200 equals 150 minus y, at least the absolute value. So remember, I can split this up. So e to the ln of 130 is 130, and then I have e to the negative t over 200 equals 150 minus y. Now, since we're talking about time and everything else, it's only going to be positive. Like my y can never be negative. Like we're not going to have negative salt. So I don't have to worry about the absolute value signs because this side's always going to be positive. So I have 130 e to the negative t over 200 minus 150 equals negative y. And I change all my signs. So I have something that equals a positive y. Equals 50 minus e to the negative t over 200. Okay. So now we can plug in 30 minutes. So we have 150 minus e to negative 30 over 200. Oh, I forgot the 130 when I wrote this, switched over. I'm like, something's wrong. And we use Desmos. So we get 38.1 kilograms of salt in there after a half hour. Okay. What's going to happen over time? It's going to keep getting saltier. Okay. So will it ever have 1,000 kilograms of salt? Why?
Water.
Okay. So what's the maximum amount of salt it can have?
The ratio that it's being put in.
Which is?
0.03.
Right. So multiply that by the
Or sorry, 25 liters.
Nope. You were right the first time.
But it's
The 0.03. So it's 25 liters per minute, but the salt coming in, the salt content is what we're looking at. And if you did the 0.03 times the 5,000, you got 150. So this number right here, e to the negative, that's going to get smaller and smaller and smaller, right? Because this is technically 1 over e. As that number gets bigger, the number that goes to 0, correct? So as this number here gets bigger, so it's 300, 3,000. As that number gets bigger and bigger, it's basically this term right here is going to 0. So my limit for this is 150. So given enough time, my maximum amount of salt that I can put in would equal the water coming into the tank. And that's the 0.03 kilograms of salt per liter. Okay. That's why I solved it for 0, because I wanted you to be able to plug in other numbers to see what's going to happen as we go on. And if you had it in terms of the other thing, it wouldn't have been able to easily figure that out. Okay. That's a mixture problem. That's actually a problem that is used often. Another one that's also often used is the actual concentration of a drug in your system. Okay. If you think about it, if you're taking any kind of medication, that drug in your system builds up over time because it doesn't decay as fast as you're taking it. That's why your doctor tells you to take your antibiotics every single day at the same time and not to stop when you start feeling better because it's building up. So if they give you 100 milligrams of a drug, they're actually not, the actual concentration in your bloodstream they want is not 100. It's higher than that. And that depends on the decay rate of the actual drug. Huh?
Interesting.
Yeah, it's like it's formulas like this on how they actually do it. And the problem is if you don't take them the same time or relatively the same time, as the thing decays, it would drop down below and you're not going to get that jump of where the doctor actually wants you to be at. So that's also why people become addicted to things. Because whenever you take something, it never actually completely leaves your system. It gets smaller and smaller, but never completely leaves your system. So if you're addicted to something, when the level drops below what your body requires, that's when you start to have your effects. And that's when you need your next fix.
Like headaches.
Exactly. Caffeine is a highly addictive substance. Okay? And something that's extremely hard to get off of. It's just as bad as nicotine in that respect. All right? It's hard, and that's the thing. When the caffeine level drops low enough in your body, you get headaches. You start to feel those things. Same thing with sugar. You get the sugar crashes. When your sugar level drops below a certain amount, you start to have effects. That's what happens with diabetics. And it's all the same concept as what we just did here with the water and salt. All right. And to figure those formulas out, at some point, yes, your doctor doesn't have to do it, but somebody did. And they used calculus to do that. So
I'm a barista, so you're basically saying I'm a drug dealer.
absolutely.
Yeah.
She's a
I
barista.
said I work at Starbucks, so I said, so you're basically saying I'm a drug dealer.
It's a legal drug, but it's still a drug. This is my problem that I have with drugs in general. It's like we have legal ones that are just as addictive. So
Imagine like the collapse. If like let's say everyone gets their coffee, everyone in every job, industry. If all of a sudden, give them 2 days, they could not have their coffee. I wonder what happened.
chaos. Actually, what would end up happening is lots of headaches, almost no productivity at all, because they don't want to sleep. But give it a few days after that point, and they won't have any effects. Caffeine is one of those drugs that typically gets out of your system pretty quickly. I mean, like you can wean yourself off of it pretty quickly. It's just a matter of do you want to?
I feel slow.
Yep.
I don't have
Software crashes by coffee.
Pretty much.
But I genuinely feel slow.
Yeah. Really watch the coffee quantity every time.
It stays the same.
Yeah.
It always stays fixed.
And so coffee never goes down, and alcohol goes up. Because that's a legal drug that people can take to swallow away their pain when they don't have any money. And so that typically is what happens. All right. Review next Tuesday. Text next Thursday.
All makes sense.
There is reasons for it all. Just at some point, depending on your career, you might do this, you might not. But no matter what career you're going into, you're using it because somebody else has already done it for you and giving you the information. We were talking about before, if you've done anything with statistics, you'll know the z-table. The z-table tells you how much the probability is. Well, z-score will tell you that thing, and then you can use the z-table to find the probability. That area under the curve is all calculus. But when you're doing statistics, you're never taught that. You're just taught use the table. But somebody had to create the table, and they created that table with calculus. So, all right, I will see you on Tuesday. Bye, Max. Max is online. He's a kid that sits up here. He wasn't feeling good.